When it comes to our brain, there are many things that we wonder why they happen. Why did some people see the dress in blue and black, and why did others see gold and white? It's the same dress, so how are our eyes also different? This is also very true when it comes to our ears. This is called auditory illusions. The auditory illusions really made people think when the video went viral on the internet of someone saying a word where some people heard Laurel and other people heard Yanny. These are two very different words, so why were people getting so confused when they were being said? When there is other sound at the same time, our brain has to work twice as hard to make sure that we are giving a full sentence. Our brains try to fill in the blank space to give you a full idea of what should be said. Often, this is where mistakes come into play. For example, watch this video first with your eyes closed.
Ba 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 ba.
Okay, now open your eyes. This is called the McGurk effect. This time, you'll be watching the video with your eyes open. Look to see if you notice anything at all different now that you are watching the man.
Ba 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 ba.
Now we will watch the video with you watching and all the clips that are now next to one another. As the clip goes on, switch from one to another to see if you hear anything different based on what you see the man's lips doing.
Ba 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 ba.
The reason being your brain is confusing your sight and your hearing. When you are only using your ears, your brain hears one thing. But when you are using both of your senses, it is a lot easier for your brain to understand what it's trying to comprehend. We are now going to talk about the auditory illusion that got everyone originally wondering.
Laurel, 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 Laurel.
Because the recording is such low quality, this is a big reason as to why people are hearing it different from others. Whereas if this recording was of better quality, you would not be confused as to what you are really hearing. According to Brad Story, who is the Associate Department Head of Speech, Language, and Hearing at Arizona State University, that the main reason as to why two different names is being heard is because of the frequency people are hearing them at. When listening to speech, we tend to pay attention to three different frequencies. The lowest of the three frequencies is absolutely essential for the L's and R's, the consonants that make up Laurel. So when you're listening to Laurel, the reason you get L, R, and L is because of the movement at the third frequency. The reason why you may be hearing Yanny is because Yanny has almost the same pattern as L, R, L in Laurel. So if you listen to the recording and are hearing Laurel, that is because you are picking it up on a lower frequency. If you're hearing Yanny, it is because you're picking up on a higher frequency.
Laurel, 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 Laurel.
To further break down this illusion, Benjamin Munson, a professor of speech, language, and hearing sciences at University of Minnesota, created a spectrogram. Now, if you do not know what a spectrogram is, it is the visual representation of frequencies. The dark bands on the spectrogram represent what are known as formants, which are frequencies that resonate the loudest. Vowels pronounced by humans have multiple formants, but the first two formants, F1 and F2, are crucial to determining what the vowel sounds like, such as whether you are making an E sound or an OO sound. But if you just zoom in on this clip, you will see that there should be a second format. There are just speckles that appear random. One thing about this signal is that it is hard to track the F2. This is perhaps the first ingredient into why it is so susceptible to being identified differently. The F2 is for some reason masked. The clip doesn't end there though, Munson said. If you zoom out again and take a look at the entire spectrogram, there's something else going on. You see some faint stripes that look like lighter gray formants at those higher frequencies. Those shouldn't be there because humans can't produce those, Munson said. That the higher frequencies formant sequence may be due to someone talking in the background. But it turns out that there isn't actually another voice in there. It's just the same shenanigans, as Munson called it. It doesn't happen with human speech. Why this is going on in the Laurel/Yanny clip is less clear. One possibility is that the format pattern at the higher frequencies is just Laurel transported to higher frequencies, and the Laurel sounds like Yanny at higher frequencies. Another guess is that Laurel and Yanny got smashed together, but in the end we're still unaware as to what is actually going on, so it really comes down to how our brains pick up on the sound and interpret the frequency.